know, sometimes the other class did.
I was gonna say, like, I never saw this. Okay, so can I just press y equals and go to another row? Like
No, you want
y2.
to you want to go back to your home screen to do this.
Okay, so second y equals. No,
Just
y
second
equals
quit. Second quit.
second.
So
Um,
second and then quit is above mode.
uh, okay,
This is
minus.
I call this your home screen. I don't really know what it's
Yeah, that's a
actually
good way to put it. Okay, minus 0.0082 times 72 squared plus 0.746 72 plus 13.479 equals 24.6822.
Right, you got it?
Yeah.
Okay. Number 5 is asking about the y-intercept. I'm sorry, number 4 is asking about the y-intercept. So
Uh-huh.
what is the x value of y-intercept?
The y-intercept is peak miles per gallon for speed or whatever, right?
Y-intercept is where it crosses the y-axis.
Yeah.
Vertical
So
axis. What's the x value there?
um, I don't know.
0. Oh, am I not
Zero.
sharing that? I'm not sharing that. Okay.
Oh, okay. My
So
bad. I
that's
was
okay.
like doing a shot in the dark.
Still okay. Still okay. The y-intercepts are across the y-axis. That's when x is 0. So you're putting 0 into this function now.
hmm
You're finding
So
f of 0.
f of 0 equals, and then I'll just do the same thing but multiply them by 0. Or it'd just be 13.479, correct?
There you go. That's good.
0.479. I guess that makes sense because y-intercept has to have a 0 and then the numbers. So
Okay. All right. So to do number 5, we're going to go back to the graph, and we're going to actually go back to the calculator as well. So we're interested in the vertex.
uh
The vertex is roughly there, I'll say. And the calculator can determine the vertex for you. It's a second max.
second calc. Where is calc? Um,
It's on the top
there
row
it
there.
is. And then second calc maximum. Enter. Looks like it is 30.279.
It says left bound.
Yeah, left bound question mark.
So you choose a point left of it. So use the D-pad. Use this D-pad to move until you get somewhere left of it.
And click enter.
Hit enter. Then it's going to ask you for right bound. You get somewhere right of it and hit enter. And then you guess at the same spot.
So, go and then click in the middle or click the right
Somewhere
bound.
right. The guess can be at the right bound. It can be exactly there.
Is it fine if I moved it and it won't be the exact same spot?
Yeah.
Okay. The maximum is 30.44. Or 30.5, I guess, if you want to round it.
What's the y value there?
30.
Oh, and then what's the x value?
Uh, 45.
Okay, so give me the ordered pair one more time. That way I don't have I don't think I've got it here. What's the ordered pair?
The ordered pair
Yeah,
is so redo what I just did.
if you don't have the numbers, yeah, that we need them both for this.
Okay. So I'd click second calc maximum left bound, go more to the left. Enter right bound, go to the right. It's just taking forever. Boom. Guess. Maximum is okay. X for maximum is 45.48 and Y is 30.44.
Okay, all right, that's good. That's the vertex there. All right, we're gonna come back to 6. We're gonna do 7 next. 7's again on the calculator.
So what are the increasing and decreasing
We're gonna
intervals?
come we're gonna come back to that.
Oh, okay.
Okay, so let's do 7 first. So the x-intercepts are right there and there. Okay, so the way to
Mhm.
calculate them is you do a second calc. I think it's a 0 on there, and you'll see
Uh-huh.
that it again asks for a left bound and a right bound.
So go left of where that intercept would be.
Yep, and then a little bit right of it, and then guess, and it's in the same spot.
Um, negative 15.44.
Okay, and do the same thing for the other one.
All right. Second calc 0. Go. So left bound would be on top, and then right bound would be below. Click it again. 106.42. Does that seem right?
So that's correct.
All
Okay,
right.
now we actually need to do 8 first, and then we can talk about 6. Such a terrible
Okay.
question.
That's all
Um,
good.
okay, what is the reasonable domain and range in the context of this problem? So think about what you're doing. What's the physical situation here?
Um, I am driving a car on the highway.
Okay, so can you drive the car negative miles per hour?
No.
Can your miles per gallon be negative?
No.
Okay, so um, this is why I asked you for the vertex. Let me grab it one more time. 45, we'll just call it 45 and 30. Um, the domain is the values that are reasonable for miles per hour. So how slow can you be going 0 to your range, which is 0 to 106?
Hello?
Yes. Are you able to hear me? Exactly. Let me know when you're back.
Um, can you hear me?
Yes,
Okay,
I can
sorry,
hear you
my
just fine.
computer disconnected from the Wi-Fi.
No
The
problem.
last thing you were saying was you were just starting to put down those points on the drawing there.
Yes, these are just the y-intercept, the x-intercept, and the vertex. Because we
Oh,
know that the only reasonable miles per hour is from 0 to 106. Like we can't.
so the story is we started at 0 miles per hour,
Right.
and then we went to 106, and then the line going down is representing the gas.
That's right. Like it's not reasonable to have negative miles per hour. It's not reasonable to uh you know um have negative miles per gallon.
Yeah.
Um so your domain is 0 to 106. Your range is 0 miles per gallon. That's down here. That's not very good. All the way up to the y value here, which is about 30, you said.
Main range 0, 30. So then, do I need to write it like x slash xer?
However your teacher wants it.
I think that's how they prefer it
Okay.
with the numbers, but I don't know. So it's like I don't remember the proper like terms by heart, but
Okay, yeah. Yeah, so like if they're doing it that way, it would be x such that x is an element of the real numbers, comma 0 less than or equal to x less than or equal to 106.
uh-huh. And then it would be the same for y, just with a different number, obviously.
Yeah.
Zero less
Y
than or
such that y is an element of the real numbers, comma 0 less than or equal to y less than or equal to
30.
30.
All right.
So the real issue with this problem is that you don't know whether you're evaluating the function like without context or the in context function. So yeah, that's one of the issues here. All right. So the next problem is number 5, 6. I don't know. We're going back to the increasing, decreasing. That's number 6.
Oh.
So
So
I'm going to
should I take?
graph. But
Oh,
you don't
sorry.
need.
Go on.
Yeah, you don't have to do anything for. I'm just going to keep referring to this. So increasing is from there to there. It's the x values. Increasing and decreasing is always the x values. So it's increasing from 0 to 45,
Hmm.
and then it's decreasing from. Let me shade this. Again, it's the x values.
Would it be decreasing from like 30 to 0?
X values. 45 to
45 to
106.
106.
It's always the x values for increasing and decreasing.
Okay. Always x values. Um. Okay. I'll have to practice this one, I guess.
Yeah. Do you want us to do the other um, graphing problem there, number 2?
Yeah, like part B or whatever it's called.
Sure. Yeah. Let me find it.
Yeah, because I think honestly, like tomorrow we can go over unit 3 pretty briefly just because like I just did this and it's like I know how to do it. But with unit 1 and 2 are just the ones that like I remember unit 2 a little bit better than unit 1, but I think we should just do part B like the other side of that page like you said.
Okay. This one's got a lot of the same elements as the previous one. It's a, it's a real equation function, but when you put it in context, you realize like there's, you don't need the whole graph. So
Uh-huh.
let's graph it and get it into a proper window. That's really the hardest part is getting the window right.
Um,
So some
Wait, I
ideas. Some
so
things that could help here. Make sure you clear out the old one, hitting the clear button.
in the y equals
Yeah. And then just make sure you enter it correctly. It really is the source of a lot of errors.
9 x squared plus 16.5. Okay,
So
so I got all that
see,
typed out correctly.
I even just did the classic mistake there. I entered it wrong, left out a digit. 0.339x squared, 16.57x. Okay. Now, because we had the other window up, you might try it. You might just hit graph, but you'll realize like, nope, doesn't really fit. Looks like we need to go more up, a lot more up actually, and maybe not as far to the right and left. So we'll go back to the window, maybe go not just out to 100 this time on the right, but the
Sorry, you just clicked window, correct?
yes, window. But I'm gonna go up to maybe like 500 and change my scale to 50.
And 50. Okay. So then we just click graph,
And
correct?
graph again, yeah. Maybe you get a little better thing here. So I'm gonna go up a little bit higher. I'm gonna bring in the left a little more, and I'm gonna go down a little bit. So I'm gonna go Y max. I'm gonna go to 1,000, I guess. Y min,
1000.
I'm gonna go minus 500, and I'm gonna change the Y scale to 100, and then I'm gonna leave those other numbers alone for now.
Oh, that should be
It's just
good.
it's just an iterative thing. You just go till you get
The
that
full
looks
thing.
good. Looks good to me. So once you get that, you're in pretty good shape.
So then, okay. So
So there,
sketch it, I guess.
yeah, sketching is the first thing. The the thing is on your paper though, you don't again, we kind of I glossed over this, but you because it's a physical situation, you really only care about from zero to whenever it hits.
Yeah. Let x 0 represent that. Okay, so the y-intercept means like the starting point. I'm
Yeah.
assuming, right?
Yeah. Yep. So when x equals zero.
When it so I guess when the cable network subscription started, when
Yeah.
cable subscription started,
You might provide the year like 1980.
started 1980. What are the x-intercepts? So then for x-intercepts, I would click um
Second, well, zero.
second calc 0, and
And
then let's
you
do the
gotta go left,
leftmost.
left,
So like
right, and guess.
so x equals negative 15.29, negative 15.29, and second calc 0, left bound would be 64.20.
Give me one more time. 60,
64.20.
64. Okay. All right.
And then now that I think about it, the first x intercept doesn't really matter.
That's right. We're gonna learn it's really a mirror image of the first problem. Like if you were just graphing the function, it's fine, but in context, it doesn't make sense. Um,
Yeah. So I guess context of the story is when they had 0 cells.
well, that's where I mean, if you could have a dialogue with whoever wrote this, you would ask him like, "What did you want us to do here?"
Oh.
I don't know that you'll get an answer, but the question five there, well, what do they mean in context of the story? The one out on the right is more meaningful. That's the one when there's going to be no more cable subscriptions,
Oh. Yeah,
which
because the other one like doesn't make sense.
so um, the number five here. is asking you about 2030. What x value does that equal?
Um, so I'm multiplying 2030 within those x units.
No. What does x equal 0 correspond to? What year?
1980.
Okay. So if you go to 2030, what x value is that? How many later is that than 0?
Um, sorry, just repeat that. I just didn't catch that.
Well, you're going from 1980 to 2030. How much greater? How many more?
50 years.
So x changes from 0 to 50 now.
50. So then I will insert 50 into the original equation.
Yeah.
Okay. So then second y equal no second quit um minus 0.339 x squared. No x 50. 50 squared plus 16.579 x plus 332.875. Oh, I didn't make the x a 50. The answer would be 1,535.
So it can't be that big. We know the max is somewhere there. Yeah, I don't know, somewhere around like 600. So
Um,
you're putting it into this equation, right?
yeah, I don't know
Okay.
why it's because I'm multiplying it by 50, right?
Well, you're putting it in for x. The first one you're squaring it. So minus 0.339 times 50 squared, 16.579 times 50 plus 332.875.
Oh, um, I think. Would you mind just typing that one for me, just because like I don't want to just pre-type out that whole row if you don't already have it. If not, I'll do it.
No, I gotta just gotta share that and I
Clear,
already have the
clear.
answers from with other students. So,
Yeah,
um,
fifth
so it's
one.
minus 0.339 parentheses 50 squared.
Yes,
All right. Plus,
plus 16.579 parentheses 50 plus 332.875. So then you got a different number than I did.
we must have
Three.
it entered differently. That's the only way.
Yeah. Okay. So I guess in 2030 there will be 314 subscriptions.
That's in thousands. And really to try to get it to where you're entering it correctly, because obviously I'm not taking the test, so it doesn't matter
Yeah.
if I can do it or not. I'll take a snip as well and put it in this notes. It is one of the limitations of this format. I can't see what's on your screen. If I were right there next to you, I could tell you exactly what the issue is. But
Yeah.
I can't. You just have to look number by number.
Just make sure I always do
You'll
it right.
eventually figure it out.
Maybe it's like a setting or something. I don't know, just because I have the same numbers, but um
All right, so the next thing is where it's increasing and decreasing. So what you really need is the vertex. Could you calculate the vertex for us, please?
Yes. So I'd go back to graph. Second calc maximum. And I'd still do the left bound, right bound,
Yep, that's right.
left bound, right bound, and the maximum is 535. Or, well, you want the x and y coordinates for it, correct? So that'd be 24.45 for x, comma, 535.57 for y.
Okay. I'm sorry. What was the X value one more time?
24.45
Okay. So
and
yeah, questions.
535.
Yeah, we actually don't need that. For the range, we would.
So we only need, for decreasing interval, we only need x.
That's right.
All right.
And then
Only.
this other one on the right you found was 64.2. So increasing, and it's going up and to the right. Decreasing, it's going down and to the right.
Decreasing 24.45, 64.2. Okay. Um, I guess tomorrow I wouldn't mind just kind of going over those just like one more time. But I
Sounds good.
think like as a whole, it's just kind of like it's not necessarily hard. It's just like remembering the steps with a calculator and knowing like which number to put where.
Okay. All right. So where should we go from here?
I think we could start the unit 2 page, question 1, because I don't know, it's not that. I think yeah, I'd like to do that one.
Okay. This piecewise graph has two pieces. It's got a top piece and a bottom piece. Could you tell me which piece
Um,
each one of these would use?
so it would use the top piece.
For which one? -3?
Number 1.
Okay. How about for -1?
-1 would be the second one,
All right. And 0?
and would also be the second.
Okay. So go ahead and evaluate that for us, please.
And I'm just putting it in for like it's 3 times -3 plus 7.
If you're using the first one, yes, which you
Okay.
are.
Equals -9 plus 2 minus 2. -1 squared is +1, so then -4, and then 0, -5. So -2, -4, and -5. So then my question is with that, are those coordinates that I'm gonna put on the graph? Like I don't understand what I do with these.
You don't do anything with them. The part B is where you're going to actually end up
Use
laying
okay,
out the
wait, so
graph.
then is A just like practice to be like know how to do it pretty much?
I guess that's, there's, yeah, I mean, B is really where it's at. So,
Okay.
um,
So then has to be less than -1, so then -2, -3. So then -1 would be -3 plus 7 equals 4, -6 plus 7 equals 1, -9. So then the coordinates that are missing is 4, 1, and -2. And then the other one has to be 0, +1, -1 becomes +1, -4, 0, -5, -5, 1, -5, -4. So now for the other 3 missing coordinates, it's -4, -5, and -4.
Okay.
So then just to put those onto the graph, I'll start doing that. So minus
Before you do
1.
that though, when it's less than, that's an open circle for the first one.
Uh-huh. And closed circle for the second.
Yeah, it's really important that you make note of that so you don't, you know,
I
come
remember it like, okay, the one with the line isn't the is like more filled in
exactly.
like the line or
Yeah,
something.
exactly.
Minus one, 1, 2, 3, 1, 2, 3, 4. Minus 2 and 1. Minus 3, minus 2. And I'm gonna give them their own lines, correct?
Well, this one's going to the left, this one's going to the right.
Uh-huh.
Now,
And the
but the
one
one on
going
the
to the left is pointing down.
right, but the one on the right's not a line. What is it?
It is a uh oh shoot. It's a I know it's like the curved, I forgot the actual name they want me to use, but it's like
That's
a
okay.
V, a U.
That's okay. So it's the U-shaped one. Now, you might consider graphing a few more points, like 2 and 3, to get the full
Perfect
shape of it.
line going.
Yeah, otherwise you're taking a chance that you don't get the whole thing.
Uh-huh.
Or, like, well, how do you know? Like, well, I don't know if that's okay with your teacher, you can do that.
I think it is okay, thankfully, but I will definitely keep that in mind. Um, oh, wait. Okay. I drew that a little bit more funny. I made it like it's an actual U and not just a curved line that's going up.
Well, that's the whole point of this is that it doesn't go to the left, it just goes to the right. There's a
Just to the right. Yeah.
there's a
I was like,
break
something
there.
looks off. It took me a moment to get that. And then that's the line that's uh shoot, what's that line called? The asymptote
It's not an aspect, I call it the break. It's
break.
the domain is separated by
Those
at -1.
oh yeah, they both have -1, therefore the line's going on x -1. Um okay, so then for end behavior, um
We actually should do the part underneath it, the x coordinate of the discontinuity first, which you already just
oh
answered.
yeah. So then that'll just be -1. How do I know? Both lines start at that point. Is that fine to say or
Yeah.
all right,
Well,
I'm
it's
fine.
called a jump is the type of discontinuity. And because it's a literal jump. Like if you were to go from, the lower to the higher, you would have to jump.
Uh-huh. What's the other type?
Vertical asymptote and a hole.
So is a hole I don't know what a hole is. Is it just like they're the
I
same
mean,
spot?
this up here is the hole, but
Uh-huh.
it would be like if a
Oh, they're
more
both on the
common
like
problem is
exact
when
same spot.
there's a hole between them.
Okay. All right. So a jump is up and down, verticals left and right, and then
Vertical asymptote is when the graph goes like up and up, something like
uh-huh.
that. You don't
Okay.
have any of those in this course
That's good.
so far.
Okay, cool. So that's not too bad. So I guess for end behavior, that's domain and range, correct?
Uh, that's separate. The end behavior is as x goes to positive infinity.
Okay. So as x goes to negative infinity, f of x is negative infinity or something like that.
It depends on the parameter. So x goes to infinity. Let me put a label on it. That's over here on the right at A. How far up is that going?
And for forever.
Yeah, so what do we call that?
Uh, infinity,
Positive infinity.
positive infinity, and
And
then the
then,
one below is negative infinity for both.
yeah,
Okay, so then I guess middle behavior, writing words. I'm literally just
That's
Or you
that's
say that?
that's that's where it approaches um the um in the middle here. So it's as it approaches. We got to switch. It's this C, and then it's a D.
Uh-huh.
So maybe I guess they just want it in words. So you just would say as it approaches from the left, from the right.
Hmm.
Not really sure what they want there.
So like as it approaches from the left, it as it approaches from the left, it goes positive, and as it approaches from the right, it goes negative.
Yeah, that'd be fine.
As it approaches from the left, it is positive infinity. As it approaches from the right, it is negative infinity. Okay. Yeah, I guess
I would try to see what you can do on your own here. You can see
yeah.
we can't get through. We cannot like do everything, and so
uh
and some of this you can do, especially the stuff you've done more recently. You'd be more
Yeah, like
familiar.
all of unit 3, I'm pretty sure I can just do by myself.
Yeah, so we got another lesson tomorrow at 5, and
Mhm.
we'll just go from there. So that'll do
All
it
right,
for
cool.
us, Zach. We'll stop there for today. We'll pick up there tomorrow.